Hey, what's up guys? Andrew here. Today we're going to be covering the next question from Leetcode in JavaScript. I'm going to go ahead and share my screen with you. So this third question is called longest substring without repeating characters. Given a string, find the length of the longest substring without repeating characters. They go ahead and provide an example, ABC, ABC, BB. So I went ahead and put these characters from the example into a notepad so I can zoom in a bit better and highlight them as I go through them with better contrast than available with the browser. So what we do is we start at the beginning of the string and we start counting. So ideally, in order for our algorithm to be good, we would really want it to be linear runtime, which means that we're just going to go through each character in this string once and perform a set number of calculations on based on where we are in our current loop. So let's go ahead and try to think about how we could go about solving this programmatically or strategically. So let's start with the first character. So far we have a length of 1. We store that in memory. Let's now go on to the second character. We have a length of 2. Good. That's possibly an answer. We go on to the third character. Length of 3. Good. The tricky part is when we get to the fourth character, because there's a duplicate here. So in this current substring that we're examining, we have a second A character. So we cannot increase the count to 4 for the longest substring that we found so far. It's still only 3, ABC or BCA. So what do we do here? Well, after we've noted that still the max is only 3, we also need to figure out where to start examining next. We could technically start like some random place and just continue from where we left off, but that would kind of be missing out on like some of these that I'm highlighting right here. So we don't want to just kind of start with the next letter and continue. Instead, what we want to do is we want to or at least the way that I've found is rather strategic, is to look where the previous duplicate was within the substring that we're currently examining. So we find that previous duplicate of A, and then we start with the next character. So we start with B here. And then, so we currently are examining this substring since we were already iterating through this original string, and we already arrived at the second A character, which is index 3. And then we continue from there. So next we move on to the next character, which is B here. So we're currently going to be examining BCAB, but we hit another duplicate character. So we're going to follow the same process. We're going to go back to the previous B character, and then start from the next character, which is C. And we already have all this highlighted because our in the overall string we've already iterated to this B character. And then we go through the next iteration of the loop, and we're gonna have this is what we're gonna be examining. However, the newest character is a duplicate. So we bounce back to the previous instance of it, the previous duplicate, and start examining from the character immediately after that duplicate. We're basically stripping out the previous version of the newly encountered duplicate and continuing from there. So next up, we bring in the new character from the overall string, duplicate. So we bounce back to this previous B instance, and so now we're going to be starting from here. And then we bring in the new character, but there's a duplicate, so we bounce back to this previous character and then go to the next character after that. So this is just of length 1. So overall, if you had been recording the length of the valid substrings without duplicates, the answer is indeed 3. So we have ABC, BCA, CAB, ABC, BC, CB, and then B. So the length, maximum length of those items I mentioned is 3. So that's the strategy that we're going to follow when coding this. So let's go ahead and put that into code. So first off, let's handle the trivial case where S is null or S is the empty string. Then let's go ahead and create variables to store the starting position of the current substring that we're going to be examining. And we know it's not going to be length 0 because we already handled that trivial case. And we want to return the max length that was found. And as I mentioned earlier, we're going to be looping through the string. Okay. So let's go back to this notepad that I was demonstrating with. So we need some kind of a substring to be currently examining. So let's go ahead and define that substring in code. It doesn't really matter whether or not we include this newest character or not, because the way we're going to be searching within the substring, we're going to be using the index of method, which returns the index of the first matched character. So we could do a plus 1 here. I'm going to go with A. It doesn't really matter whether we include the 8th element in the substring that we're returning. So let's continue. So we have the substring, and then as I had mentioned, once we find a duplicate, we wait until we find a duplicate. So ABCA, we hit a duplicate. And then we want to find in this substring, we want to find the where that repeated character occurred. So we want to find where this A was occurring in this substring. Or technically, as I mentioned a minute ago, it could technically be the first instance of it within this substring that I'm highlighting right here. So either of these two substrings would work. But we want to find the value or the character that we're currently at in our overall loop. So I'm going to make this variable name extremely verbose just for the help, for your sake. So character's previous index in observed substring equals substring dot index of, and then if we go back to our example here, so if, for example, we've been through this, we've been through that, we've been through that, we've been to this. So this A character that I'm kind of flashing on and off, that's the current character in this overall string, and that's what we're trying to find. So we're finding, we're trying to find that character. So it's S at the current index. That's the character. So now we know where within the current substring that we're at, we know the index of the previous duplicate. So go ahead and write an if statement real quick. So if we went ahead and found such a position, it'll be greater than or equal to 0. Otherwise, index of returns a -1 value when it's not a duplicate. A duplicate was not found. So when there's no duplicate found, that means we're good to go ahead and just increase the length of the current substring. It's kind of like a counter because there's no duplicate, so we know it's just part of a valid solution or potential solution. So after we increment the counter, we say if that length is greater than the current max, then we got to update the max value. Okay, and the tricky part is what happens when we did find the duplicate value within the substring. So when that happens, we need to do a couple things. First, we need to calculate where the next substring of interest will be located, meaning where it starts. So we have a variable for that, start of observed substring. So we go ahead and set that equal to something. Now let's go back to our example here. So suppose we have the current, we're observing these 4 characters so far, and we find the duplicate A. We bounce back to the first A, and then the new one is going to start at the 1 character after that. So the start is going to be 1 after the previous one. So I'm going to intentionally make a mistake here, but I'm going to correct myself in a minute. So as I had mentioned earlier, it's going to be the character's previous index plus 1. So let's go ahead and just write that down here. And I'm going to explain to you the slight gotcha within this logic. So it would work in this instance right here. However, in this instance right here, it'll find the index of 0 because within the we're only extracting it the index from this particular substring, and B is at the 0 index. However, 0 is not the index in the overall string because this substring did not start at index 0 in the overall string. It had a starting position. So we need to actually include the addition of its starting position, because remember the substring is 1 over from the 0 index of the string. So for example here, 0, 1, 2, 3, 4 is the index of the second B. 1 is the index of the first B, and we want our new string to start at C, which is at index 2 of the overall string. So how can we get to 2 in terms of calculations? Well, the substring currently starts at 1, so we have 1, and then there's a hard-coded 1 at the right side of the equation on line 17. So that's 2, and then the character's previous index in the observed substring is 0, because that's where the B is located within this given substring. So that does match. We got 2 as the value, and 2 is indeed the index where we wanted to start the next observed substring from. So that's just a quick sanity check and make sure that our equation makes sense. We can actually do a shorthand notation here using plus equals, since we have x equals x plus something. We can just use plus equals. And when in doubt, I wouldn't recommend hesitating to add in some extra sets of parentheses, where it might help add some clarity to your code and reduce some ambiguity for those who aren't 100% up to speed with the order of operations in the current language. It really helps for readability sometimes to just go ahead and, when in doubt, just go ahead and add in a little bit of punctuation to help your peers out in making your code easier to read. So let's go ahead and we need to know the length of the newly defined substring based on the new start position. We know the end position is based on where we are currently in the overall loop. So we have a start, we have an end, we can calculate the length. In math, length equals end minus start plus 1. So length equals a minus start plus 1. And we can do a quick check on our logic here. So I'm going to pull up our example again. I made the text a little bit smaller because I'm going to go ahead and paste in this equation. And we're just going to do a check to make sure our logic is correct. So we walk through this string, we get to the first duplicate. So the new one, we calculate the new start, which is going to be with B, the letter B. So we're going to have this one as the new one. So the new start is going to be 1 in the overall string, position 1. So where is start? That's going to be 1 right there. Equals a minus 1 plus 1. And length, well, it's BCA, so we want it to be 3. So we're trying to make sure that these two sides of the equation actually end up equaling each other. And 0, 1, 2, 3. So our index value is 3 right now. So we go ahead and replace that with 3. So we just want to make sure that both sides of these equations are equal. Still question mark equals. So 3 minus 1 is 2, plus 1 is 3. Valid equality. Okay, so we have the correct equation there. So let's go ahead and run the code. And we have a rather efficient and memory effective solution. So if you like this video, go ahead and press the thumbs up button and subscribe to my channel